this is the question asked by one of my students. It's a simple question, but still very easy to lose marks on this. The question is about some compounds with molecular formula C₄H6O₂, compound A and B, and they said each has the molecular form. Each compound A and B has the molecular formula same, the functional group isomers of each other, and they react with sodium carbonate to form a gas. Compound A decolorizes bromine water, but compound B does not. So instantly, what you should think is that if it is decolorizing bromine water, meaning we learned this in our GCSE as well, there is a double bond in the structure, double bond. So that we understand. But B does not, so no double bond. Okay. And then they said each react with sodium carbonate. Now, if you remember, in GCSEs as well, we learned that sodium. So any metal oxide, metal hydroxide, or metal carbonate are alkali or bases, right? So that means, and if they release CO2 gas, if they react with a acid. So the general formula, if you remember from GCSE, is that acid plus, let's say, sodium carbonate or metal carbonate. So I'm going to write it here: sodium carbonate, the general formula, and this will release the salt, or this will form salt, carbon dioxide plus water. And they say here clearly there is a gas produced, and if this is a carbonate, the only gas it produces is CO2. And on the top, you need to remember that it's an alkali, so it must be an acid that you're reacting it with. That's why there is a release of CO2 taking place. So this confirms that this is an acid. So the only acid that you can think of is, I'm just going to write it down here, CH3, CH2, CH2, COOH. Okay, that could be the acid which is reacting, right? Now, the problem is that if this is an acid and if you look at the number of carbon atoms, there are 3, 4, 5, 6, 7, 8, but the molecular formula says only 6 hydrogen atom. So meaning it is the compound one, which compound A is clear. So if I go at the bottom and if I show you my structure, this is what a normal acid will look like with 4 carbon atoms, right? This one, yeah, right. But a problem is that it has got C₄H₆O₂. But what your question is asking is C₄H6O₂. Therefore, and they also give you a hint that it decolorizes the bromine water. So simply remove one hydrogen from here to make it hydrogen 6, and one hydrogen from here. So automatically what will happen is that your hydrogen will become 6. So C₄H6O₂, and you get a double bond in the middle. As a result, your compound would be this, the part A compound, right? So what you have justified is that it's not this will be now C₄H6O₂. It will decolorizes your bromine water, and there is an acid functional group present, which justifies the production of CO2 gas, right? Now for part B, for compound B, again the structure is C4H, molecular formula is C₄H8O₂. So you cannot have this as your structure. And this does not decolorize the bromine water. It says here clearly that compound B does not decolorize bromine water, so we can't take that. So what can be the other possibility without a double bond in the structure is that you remove this hydrogen and you remove this hydrogen and connect this carbon with this carbon and make a cyclic structure. So what I meant by that, remove this, remove this, remove. This becomes 6, and you connect these two carbon with the bond. So you are fulfilling their bonds, and also you are not having any double bond and still having hydrogen. Yeah, like this. And if you just fulfill all the hydrogen atoms like this. Remember, every carbon has 4 bonds. So this carbon, 1 bond here, 1 bond here, 1 bond here, so 4, 1 here, 1 here, 1 here, and 1 here, so 4. And this one, you can have C double bond O, and OH here because it is four carbon atoms. So you're justifying your four carbon atoms here. One, I'm gonna change the color. One, two, three, and four, and one more hydrogen will be here. So if you now count the structures, number of hydrogen, one, two, three, four, five, and six. So hydrogen six, carbon four, and O2. So that's your molecular formula. So it's a cyclic structure. So for future, please remember, if there is no double bond present and they still say there are two less hydrogen than actual, that means there must be a cycle in the structure. Okay, I hope this makes sense. Please let me know if you have any other question. Thank you.